Hello everyone, welcome to this online educational classes on chemistry. In this video, we are going to talk about the basic concepts of electronic configuration. Now, the topic that we are going to study right now is the result of a number of scientific discoveries that have taken places over the course of time. It all began in the year 1805 when the scientist named John Dalton proposed his atomic theory that all the matters that we see around is made up of teeny indivisible particles called atoms. So he imagined atoms to be solid spheres which cannot be further divided. However, as the science progressed and technology advanced, in the year 1897, the first subatomic particle, that is electron, was discovered by the scientist J.J. Thomson. So now we had this idea of atoms, that an atom consists of a positively charged spheres and these electrons are embedded over that positively charged sphere. Okay, however, the picture of atom again changed a little bit, and later on in the year 1919, another subatomic particle which were the counterparts of electrons, namely protons, were discovered. These protons were found to be positively charged as opposite to that of electron. Okay, and finally the discoveries of this subatomic particles was completed in the year 1932 when another subatomic particle called neutron was discovered by James Chadwick. So now, once all these three subatomic particles were discovered, it was a challenge for the scientists to propose models that will explain the arrangement of these subatomic particles within the atom. And now we are going to look into one of such models, namely Niels Bohr's atomic model. In this model, what he proposed was that the subatomic particles called protons and neutrons were located at the center of the atom, that is called nucleus. This nucleus has a positive charge because the subatomic particle protons were positively charged, whereas neutrons were neutral. Okay, and he also proposed that the subatomic particle electrons that were negatively charged revolve around the nucleus of the atom in fixed path, circular paths, and he named them as shells. So, according to his theory, these electrons are not static, rather than they circulate around the nucleus in these circular paths. Okay, so we are going to look deeper into this model about the propositions made by Niels Bohr on how to distribute these electrons, these negatively charged moving particles in these orbits or shells as he called them, and this distribution of electrons in these shells is called electronic configuration, which we will discuss now. So, Niels Bohr proposed that an atom consists of a nucleus which contains protons and neutrons, and electrons revolve around this nucleus in circular paths which he named as shell. He also gave this shell a particular mathematical value to identify them, and he named them as K, for which the n value is 1, L, for which the n value is 2, M, n value is 3, and so on. Okay. He also gave a formula about how many number of electrons can these shells accommodate based on the n value. So the formula was 2n square, that is, number of electrons present in a shell is given by 2n square. So if we put 1 for the K shell in this formula, we will get the output as 2. So K shell here, the very first shell of an atom, can accommodate a maximum of 2 electrons. Okay. Similarly, for L shell, we will put 2 in this formula, and this gives us the output of 8. So we can say that the L shell, that is second cell of an atom, can hold a maximum of 8 electrons in it. Similarly, the third cell will give us 18 electrons, and fourth shell will accommodate a maximum of 32 electrons. So in addition to this mathematical relationship, he also gave certain number of rules in order to fill the shells of an atom. So let us have a look on those rules one by one. The very first rule was the same that we discussed right now. The number of electrons in a shell is given by 2n square, where n is also called as principal quantum number to identify that particular shell. The second rule was the shells are filled in order of their increasing energy level, and this order was: first the electrons will be filled in K shell, followed by L shell, then M shell, and then N shell. Okay. So the third rule was a complementary to the second rule, that says the filling of shell starts only when the inner shells are completely filled. So we cannot start filling the L shell until we have filled this K shell completely. That is, if we have 3 electrons to distribute, then we cannot put it as let us distribute 1 electron in K shell and 2 electron in L shell. We cannot do this. Okay. Instead, we have to fill the K shell completely, and whatever remaining electron will go to the next higher shell. Alright. So for an atom having 3 electrons, this will be a correct representation of electronic configuration. And the final rule says the maximum number of electrons in an outermost shell can never exceed 8. So we will understand this rule with the help of an example. So let us take some examples in order to understand the rules proposed by Niels Bohr in order to write the electronic configuration of an atom. We will be taking the example of sodium atom, whose atomic number is 11. This information also tells us the number of electrons in the neutral state of sodium atom. So we will start filling the sodium atom from K shell. Okay. Now, as per the rule, the K shell of any atom can hold a maximum of 2 electrons. So we will represent this K shell by a circle around the nucleus, and we will start filling 2 electrons in this shell. Now, out of 11, we have distributed 2 electrons in the K shell of sodium atom. So we will move to the next higher shell now, which is L shell, and this shell can contain a maximum of 8 electrons. So we will again draw a circle, something like we did before, and we will fill 8 electrons in this shell. Now we have only one electron left, so we will fill this electron in the last shell of the atom, and the representation here gives us the atomic structure of sodium. Also notice that this electron are in motion, they are not static. Now let us understand the significance of fourth rule by taking the example of calcium, whose atomic number is 20, and hence the number of electrons that we have to fill now is going to be 20. So we will again start filling the atom from K shell, and this shell will contain 2 electrons out of 20. Now we will put 8 electrons in the next higher shell, that is the L shell of calcium atom. Now coming to the third shell, we have so far filled 10 electrons in the atom of the calcium and 10 are remaining. We also know that the third shell can contain a maximum of 18 electrons. Hence, if we are going to fill this shell M by 10 electrons, then this will become the outermost shell. Okay, and as per the rule number 4, the outermost shell cannot contain more than 8 electrons. Hence, we cannot fill 10 electrons here. Rather, we will fill only 8 electrons in the M shell of calcium atom, something like this. And then we will fill the remaining 2 electrons in the next higher shell, that is N shell. So the structure of calcium will be something like this instead of 2, 8 and 10. Alright. So the atomic model proposed by Niels Bohr was actually the beginning of understanding the structure of an atom. It was not the final proposition, it just gave us an overview of what might be happening inside an atom. Later on, a number of theories were proposed in order to explain the structure of atom with more accuracy, and we will move towards this so-called quantum mechanical model of atom from our next video. Thank you.